Hi friends, today we are doing acids and alkalis. Before we get on to the video, make sure you like, subscribe and share. And comment down below the answers for the questions. Acids. Water, vinegar, warmer and lemon have in common. They all taste sour. This is because they contain acids. Warmer includes an acid from the stomach, hydrochloric acid. This acid helps digest foods. Vinegar is a solution of ethanoic acid and other substances. Lemon contains citric acid. Overall, acids are a chemical species that donates protons or a hydrogen ion and accepts advances. Acids can react with other substances and form salt. Some acids burn or dissolve other substances that they come into contact with. What are alkalis? Alkalis are bases which are completely soluble in water. Sodium oxide and potassium oxide are alkalis which dissolve in water to form bases. An example of an alkali is sodium hydroxide. Alkalis are the chemical opposite of acids. Soap solution is an alkali and so is toothpaste. Most alkalis feel soapy. Using acids and alkalis safely. It is safe to eat the acids in lemons, to use alkaline soap. But there are some hazards linked to some acids and alkalis. The bottle containing the substance has a sticker in it which has a symbol. The symbol shows that the solution in the bottle is corrosive. It can burn your skin and eyes. You can control risks from corrosive solution by wearing safety goggles and gloves. Concentrated or dilute. Pure ethanoic acid causes severe burns. It catches fire easily. Vinegar contains ethanoic acid. It is safe to eat and does not catch fire. Why is there a difference? Pure ethanoic acid contains no water. Dissolving in water changes some properties. The amount of water makes a difference too. Acid A has 370 grams of hydrogen chloride in 1 liter of solution. Acid B has 3.70 grams of hydrogen chloride in 1 liter of solution. Acid A has more hydrogen chloride per liter than acid B. Acid A is concentrated, but acid B is dilute. The concentrated solution burns skin and eyes. The dilute solution hurts if it gets into a cut but has no other hazards. The hazards of using acids and alkalis depend on the acid of alkali you are using and whether the solution is concentrated or dilute. Question time! List the chemical names of 3 acids. B. State 2 hazards of using a corrosive solution. 3. State the difference between a concentrated solution of an acid and a dilute solution of the same acid. Make sure to comment the answer down in the comment section below. Indicators and pH. A student has 2 beakers. One contains an acid and the other contains an alkaline solution. How can he find out which is which? You can use an indicator to find out whether a solution is acidic or alkaline. An indicator contains a dye. The dye turns a different color in acidic and alkaline solution. Which plants make good indicators? You can make indicators from plants. The table shows the colors of some plant indicators in acidic and alkaline solutions. Litmus indicator. In science labs, you might have used litmus paper. Litmus is a solution of dyes from lichens. Red litmus paper turns blue on adding alkali. Blue litmus paper turns red on adding acid. How acidic and how alkaline? Which is more acidic, vinegar or stomach acid? How can you find out? You can't use litmus paper. Both acids would make it red. Instead, you need universal indicator. Universal indicator is a mixture of dyes. It changes color to show how acidic or alkaline a solution is. What is the pH scale? The pH scale is a measure of how acidic or alkaline a solution is. On the pH scale, an acid has a pH of less than 7. The lower the pH, the more acid acidic the solution is. An alkaline solution has a pH of more than 7. The higher the pH, the more alkaline the solution. Some solutions are neutral. This means that the solution is neither acidic or alkaline. The pH of a neutral solution is exact. Question time! A. State what an indicator is. B. State the color change when a student adds an acid to blue litmus paper. C. State the pH of a neutral solution. Neutralization. Have you ever had stomachache? Did you take an indigestion tablet? Extra stomach acid makes your stomach hurt. An indigestion tablet reacts with this acid in a neutralization reaction. In a neutralization reaction, an acid reacts with the substance that cancels it out. The pH gets closer to 7. Which substances neutralize acids? A base is a substance that neutralizes an acid. Bases include sodium hydroxide, calcium oxide, and copper oxide. Some bases are soluble in water. A soluble base is an alkali. How is neutralization useful? Soil for crops. Some soils are acidic than others. Every plant has its favorite soil pH. Deepa lives in India. She has a farm. She wants to grow tea. She tests the soil and its pH is 4.5. The soil is too acidic to grow tea. Deepa adds a base to the soil. The base neutralizes some of the soil acid. The soil pH increases to pH 5.0. It is now suitable for growing tea. Acidic lakes. In some places, gases from burning coal make sulfur dioxide gas. The gas dissolves in rainwater to make acid rain. The rain falls in lakes, making lakes more acidic. Some water animals and plants cannot live in these lakes. Environment organizations may add bases to acidic lakes. The pH of the lake water increases. Question time! A. State one difference between a base and an alkali. B. State what volume of sodium hydroxide was needed to neutralize the acid. C. Describe two situations in which neutralization is useful. Thank you. Presentation by Niki.